All right, welcome everyone. Thank you so much for joining today for Take Advantage of Your Vertical Services. We are here with Terri Oswald from the Mitrex and Cladify team, who's going to be teaching us all about how to integrate building integrated photovoltaics into architectural projects. So super excited to get to today's CEU course. Before we go ahead and get started with the AIA-approved part of the presentation, my colleague Helen, Acelab's Director of Architect Experience, is here to give a quick little intro about Acelab, show you guys how to get in touch with the team at Mitrex and Cladify after today's event if you've got any follow-up questions or want to connect with them about a project, and some next steps and what to expect in terms of follow-up after today's webinar. So I'll go ahead and let Helen take it away whenever you're ready.
Cool, thank you. Hey everyone, I'm Helen, and I'm going to talk a little bit about what to expect and how to get in touch with Terri and her team here. And then I'm also going to show y'all a little bit of what we have coming out soon at Acelab, and seeing if any of y'all want to join me for a meeting to discuss your firm and then kind of set up a custom plan based on y'all's structure for joining our early access program for what I'll show you. So first and foremost, I'm going to go ahead and show you that lots of ways to get in touch here on Acelab. After this has been, after the webinar, you're going to get an email from my colleague Evelyn. And in that, she's going to link you to the conversation that we will set up for you. Based on what you complete in the poll today, whether that's prog requests, technical information, things of that nature, you're going to see a conversation show up. You'll also get an email from Acelab as well. But Evelyn and I like to follow up and just make sure you have what you need and you're aware that's been created for you. We will also be doing kind of some other little follow-ups with you just to make sure you have what you need. So keep an eye out for those emails. And in the meantime, if you want to directly get in touch, you can always go to Acelab, type in the brand name of who you might be looking for, and make sure you have brand selected here. I'm going to jump to their product page. So here you'll see some overall information. You hit this contact button. That's how you can get in touch with Terri. This is also great if you need to follow up on your CEU certificates, things of that nature. But really, she's here to answer any questions as well as the team. Some additional information here. And then scrolling on down too, you can see their products. And then you can also save these into your projects and create comparisons. Just scroll down here. Lots of great stuff. And then some case studies as well. I do love this building, so that's fun. All right, I'm going to show what's coming, and it does kind of relate to maybe I will save all of these, for example, and create a comparison. This currently exists in Acelab. Basically, our team takes a bunch of different parameters across whichever category you're looking at, and we will put these side by side for you to allow you to kind of look at these and see which might be the best option. If BIM, CADs, or spec files are publicly available, you'll see them here too. But just scrolling on down, for example, we might have dimensions, finishes. It'll vary depending, again, on what we are looking at. So this currently exists in Acelab. What we're launching this summer, but only to certain folks, is schedule. So everything you have saved here in comparisons will now be in a schedule. All of these columns are customizable for you. It's a great way to keep track of what might be approved. As well as just a bunch of other information that you can add in here, the master format section, other projects that this product's been used in previously at your firm. That's a big one. A lot of people have questions on that. It's hard to track, and ability to add comments, pictures, and things like that. So this is where this is all going. I'll also say that there's going to be custom views for this. One of the things that I'm really excited about in bringing this out to y'all is the ability for y'all to have an internal view where you might be talking to each other, talking about different things. You can then create a view, hide certain columns, and then export that as a CSV and take that into your drawing sets. Again, it will be a CSV, so might be some workarounds there we can work through as well. But this is what's coming out this summer. If you're interested, I'd love to chat with you for about 30 minutes, take you through this and a couple other things. And again, kind of come up with a custom plan for your firm based on your structure, which projects you have going on. All right, I will close out here and pass it back to Terri. If you have any questions, feel free to let me know. Bye.
Awesome. Thank you so much, Helen. Feel free to use the quick poll that we launched to indicate your interest in signing up for a quick meeting with Helen, getting some access to those early tools, and learning more about how to use Acelab. Other than that, I just want to quickly mention that today's event was AIA approved. So we did ask for AIA numbers upon registration. We'll also send over a form momentarily in the chat where you can include your AIA number, as well as indicate if you'd like a certificate. So keep an eye on the chat for that link, as well as Helen's meeting link, which she just dropped in there, and some other helpful resources that we'll send throughout today's webinar. All right, that's it for me. Terri, whenever you're ready, feel free to take it away. And thank you so much for joining us today.
Fantastic. Thank you for having me. Hello, everyone. Welcome. Thank you for tuning in for today's presentation of taking advantage of your vertical surfaces. My name is Terri Oswald. I am a very proud representative of Mitrex and Cladify Technologies. I've been with the company for 6 years now, and so I'm very familiar with our solutions. I just want to give you a brief introduction on our company before we get into the presentation. So we are currently the largest manufacturer in the world of sustainable solutions, and under the umbrella of sustainable solutions is our solar BIPV technology and our non-solar BIPV technology. So we're going to get into that in the presentation, but I just wanted to give you a brief history. We've been around for 25 years, so we certainly know this industry well. And one major advantage we have over a lot of other manufacturers is that not only do we produce the technology, but we build our own buildings. So we understand very well the challenges that come in the construction process. So unlike some other companies who, come up with a technology but have never constructed a building and have no idea how to deal with corners and edge profiles and all that kind of stuff, we have that experience. So that comes under the the breadth and depth of what we offer because of that 25 years in the business. So having said that, that's a brief intro on our company. I'm going to turn off my video so I don't have any buffering challenges, and then I'll turn it on again at the end when we're getting into a question period. So let me turn that off now. I'm going to share my screen. Please confirm that you can see it when it comes up. Play from start. So hopefully we are at the beginning. Are we good?
Yep, looks good.
Fantastic. Excellent. All right. So take advantage of your vertical surfaces, energy generating building materials. And again, as I mentioned, who we are the world's largest sustainable facade manufacturer. So 20 plus years, over 25 million square feet supplied globally. We are located in Toronto, Ontario, Canada. So for all of the US clients that we have, we are literally in your backyard. Pardon me, as Bo mentioned earlier, the course has been registered for an AIA credit, so please provide her the information so that registration can be taken care of on your behalf. So to effectively combat climate change, we need to, talk about the role that the building industry plays in global CO2 emissions, and we need to shift not only how we think about designing our buildings, but how we are powering our communities. And this is not something we just say off the cuff, because think about it this way. It's like the discussion that people have about, oh, we should all be driving electric cars. Okay, well, if that is the case, then who is the onus on to produce electric cars that are affordable? Is it us or is it the manufacturers? So we believe that it's incumbent upon the manufacturers to create technology that is available and affordable. So that onus is on us. And so it's great we talk about it, but when push comes to shove and the rubber meets the road, who's actually doing it? Because we are long past just talking about it. We're doing it. So this course is going to discuss the technology. Hopefully by the end of it, you are going to be able to recall the basics of solar energy, the key components and how it has traditionally been harnessed. You're going to be able to describe what a BIPV is and how they improve on traditional photovoltaics in terms of design and performance. You're going to be able to demonstrate ways to incorporate BIPV systems and understand what the energy output and savings potential is through the market research that we're going to talk about. So, introduction. The buildings and construction industry account for roughly 30% of global greenhouse gas emissions. So how do we achieve sustainable buildings? Sustainable construction materials with low carbon embodiment, obviously, is what we need. The life cycle analysis of construction materials is really important. Integrated renewable energy generation such as BIPV and other high performing systems is how we achieve sustainability. Sustainable facades, our roots, from stone to solar. Stone cladding is what the early stages of cladding potential was many, many years ago. And then that evolved into a lightweight cladding solution. And then we evolved into multi-facing high performance cladding and now solar. So that is how, we have evolved from early stages of heavy materials and other materials to where we are today with solar integration. So how is BIPV manufactured? So this facility can manufacture up to 25,000 square feet a day. And the process is, it starts off with all the raw materials coming into one facility, and everything is custom designed and manufactured according to the specific design. So you have your solar cells, your glass, all raw materials are assembled in this facility. So, the customization process happens with is different for every project. So every project is a different design. So we don't have a standard. We produce standard panels. However, every project is very unique. And so how we, focus on the construction of that is entirely reliant on the design of the building. And we work very closely with architects to figure out what that looks like. But the fact is that the technology, the mission of this technology is very simple. So, one of the things that we realized very early on in our research and development is the fact that it doesn't matter what the nature of the building is. It's one very simple rule, and that is that every surface that is touched by the sun should and could generate electricity. That is the mission of BIPV, is to be the catalyst that accelerates the adoption of sustainable energy generating structures. So whether it is a stadium or a high-rise condo or an apartment building or a data center, it doesn't matter. Any surface that's touched by the sun should generate electricity, period. And so why we utilize BIPV technology, there are a lot of reasons. According to the IEA Renewable Energy Report of 2023, solar energy is now the cheapest source of energy in the world. And solar facades can generate a substantial percentage of the total electricity demand of a building. So in this particular case here, what you're looking at is a project in Toronto. This is a university project. The solar facade is going to generate roughly 40% of the building electrical requirements. That is a significant amount of electricity being generated by the facade. So you will significantly reduce building's carbon footprint. A building with a solar facade can take advantage of government incentives. In Canada, it's nowhere near as good as the USA. In the USA, you have a 30% investment tax credit to take care of. That's the minimum. Then if it's affordable housing or, there's other criteria, it could go above 30%, but at minimum, you have 30%. And also a solar facade can take your building from energy efficient to net zero. So I want to give a very brief overview of the history of solar. So first discovered in the late 19th century, photons carry energy proportional to the wavelength of light. So the surface will absorb the light energy, and with enough energy, that surface releases electrons, thus creating electricity. So any material that uses this are called photovoltaics. Now, photovoltaics come in either monocrystalline silicon or thin film photovoltaics. There's different types, and they can be integrated into opaque panels, or they can be integrated into glass that retains some vision. There are a lot of different applications, and we're going to go through that. So what are building integrated photovoltaics, or BIPV? They are sustainable energy generating facades at no extra cost. Energy efficient solutions for both existing and new facades. So whether it is a brand new building or you're looking to retrofit a 70-year-old building that requires a facelift, there are many applications. And there are endless surface design options. So these are the basic components of BIPV. So you have your glass facing, you have your encapsulant. The orange area is your solar cells. Those can be applied in various ways. You can either fully, you can have 72 cells on a sheet, or we can do it in a variety of different ways so that there's space in between. It all depends on the design. And then you have another layer of encapsulant. Then you have your back sheet. You've got your junction box, and then aluminum honeycomb is at the very back. And that is what gives the panels their very lightweight properties and the ability to create a lot of different designs. So sustainable solutions are both in non-active and active. So non-solar means no solar. So the facing of a panel will be either stone or porcelain or brick or aluminum PVDF coverings. There are a lot of different materials that we can apply onto the honeycomb. And on the solar facade modules, it's the same sandwich panel composition. The difference is, instead of a stone or a porcelain face, you have glass. That glass starts off clear, and then it can be customized with just about any pattern or color that you can think of. There are solar glass applications, so it's customizable cell layout and shapes, and the wiring is hidden in the mullions. There is also solar railing applications. So whether it is a spandrel panel or solar railing or windows, there are a lot of different applications for solar technology. Installation systems are really important to understand, because if you can't get it on a building easily, what's the point? There is no point. So we understand that every project is unique, and our solutions will match that. So from a rain screen to a unitized wall system to a full wall assembly, there are a lot of different systems that we can provide to accommodate, various facing materials. So CladiShield is a rain screen application system. So in this particular case, you can either have a stick build or you can have panel by panel. The advantages to this are, you can incorporate a lot of designs like recesses or projections. It's very lightweight. You're looking at 3 to 5 pounds per square foot. Again, the aluminum honeycomb makes it super lightweight. So there's a lot of things that we can do with this particular system. You can achieve irregular designs. There's precise installation. You have your continuous installation and AWB. You've got the panels can span floor to floor and be attached to slabs only. We can do a lot of pre-assembly work as well, so that all of that pre-assembly is done at our facility, and it arrives on site ready to hang. So lots of advantages to a rain screen application. It's also adjustable, so you can fit in a lot of insulation behind the panels. So there's a lot of versatility. We have our Claditize system, which basically is a precast system that is super lightweight. So it eliminates a lot of the challenges that you would typically have when you're working with precast. All of the structural support that you would typically require can be eliminated. So it improves the building's energy efficiency. It is a very quick installation. It's easy to transport on site. It reduces construction time. You have the option of installing from the inside or from the outside with a crane, or it can be installed from the inside, eliminating the need for a crane. So it reduces cost for design, transportation, and installation. So there's a lot of facing options. It's durable, it's weather resistant, it reduces maintenance, et cetera, et cetera. So a lot of advantages with this system. And then we have our full prefab wall system. This is a hybrid of curtain wall and precast architectural wall panels. They span slab to slab, transferring all the loads to the building structure. Again, you can install from the inside of the building, eliminating the need for a tower crane. and all the structural support that typically is required with heavy solutions. So a lot of advantages with this as well. Super lightweight, again, 3 to 5 pounds per square foot. The thickness of the aluminum honeycomb will change when you're dealing with a high rise. So the higher up we go, the thicker the extrusion of the aluminum honeycomb is. So depending on how tall the building is would determine, what the thickness of the panel is. Customizable integrations and special projects is where things get very interesting. As I was saying earlier, the aluminum honeycomb allows us the flexibility to create projections, cantilever designs, unique recesses and projections. Lots of things can be done in a rain screen application. Again, it's compatible with manual or automated movable panel systems, which can be an added benefit for active panels. In this particular project, these are not active panels. These are non-active solutions. So these are actual Indiana limestone facing. We were working on using Mitrex, but the decision was made to go with a more traditional facing. But again, that design can be achieved with either BIPV or non-solar. So the components of BIPV, obviously the module, there are power optimizers depending on the facing color. We would either integrate optimizers into the build or not. Inverters, obviously, because solar power comes, it's the opposite of the rock band AC-DC, it's DC to AC. So obviously we need inverters. Solar panel boards, battery is optional, transformers, isolation, disconnect, transformers, switchgear, et cetera, et cetera. So all the standard components that you would use in a rooftop installation are applied to a vertical installation. Not much of a difference between rooftop and this as far as the wiring and the connections and the components that you would require. Electrical wiring is very simple. It is a low voltage connection, so it is a male and female connection. So any installer that knows what they're doing can easily install and connect these panels as they go. Where the conduits go, how many conduits we need, how they are run in the building is dependent on the design. So we don't have a standard way of doing it. It all depends on the design of the building. The inverters can fit easily into an existing electrical room, or we obviously would make room for it in a future electrical room. They don't take up a lot of space either. Monitoring systems are part of the technology. So what this does is it gives the owner an opportunity to understand what the building is generating in real time. So you will know how much power the building is generating. You will know which side of the building is generating how much power. And once the system is live, you have the historical data. So if you're curious to know what the system generated 2 years ago on June 12th, then you can go back to that data. You will also have access to warnings. So if there is a panel that has gone down, if there is a problem, you will know about it. So it will tell you that, on the west elevation on the 14th floor, a panel has gone down. And whether that requires a replacement or it's something that you can just, discount. If it's just one panel in 100,000 square feet, one panel is not going to make a difference. So there's no need to replace it. But you will know at all times what's going on with the system. The services that are offered with BIPV design is everything from A to Z and in between. So whether it is design assist, whether it is proposal and modeling to understand how much power a building can generate, and what that looks like for the building owner, obviously the manufacturing of the panels, procurement, scheduling, project design, all those things. Right down to installation, if that is something that we can do. A lot of the projects in Ontario, we install ourselves. In the US, we have access to a lot of installers that are very familiar with our technology, and that is available as well. Solar rail. This is an area of a building that is a very easy swap out. So if a client is not ready to do cladding on their building, balcony railing is a very easy swap out. So very easy to replace a standard balcony railing with, an opaque panel or a panel that, you can actually see the solar cells. It all depends on the design, but that is something that can easily be integrated into a building design. And solar glass has a lot of, pattern and design options as well. We can play around with solar cell placement. We can make it simple straight lines, or we can do some funky designs. It all depends on what the design is. So the benefits of BIPV are obviously, the biggest benefit is generating electricity. Turning your building into its own power generation station on site is pretty cool. That's the biggest benefit. There are also other benefits, aesthetics. Certainly BIPV products offer a lot of design flexibility because the facing can be, changed to whatever color or design or pattern you're looking for. It can easily reduce energy costs. So over the course of the next 25 plus years, depending on how much active solar you can get on a building, there's a lot of reducing electricity costs for the building owner. And of course, environmental sustainability is very important. It reduces the building's reliance on fossil fuels. It lowers greenhouse gas emissions, et cetera. So those are the main benefits of BIPV. Applications. As I mentioned early in the presentation, there is one very simple rule, and that is that any surface touched by the sun should and could generate its own electricity. And there are a lot of buildings where you can apply this. Whether it's a high rise, a low rise, whether it's a data center, it doesn't matter. There are a lot of different buildings that would benefit from this technology. Solar rail and solar glass is a very large area of opportunity. So whether it is integrated into a curtain wall or window wall system, whether it is integrated into a spandrel panel solution, balcony railing, there are a lot of different ways that you can apply this technology. Retrofits, again, there's a very large a percentage of buildings that are approaching 50 plus years and are in need of a facelift. And what better way to provide a facelift for a building than making it look pretty and wrapping it up in an electric blanket so it's generating its own electricity. So a lot of different considerations when you're looking at designing with BIPV. So whether it is a solid color or whether it is a pattern that is going to replicate something like stone or wood grain or brick or metal. The power output is defined or determined rather by the color of the facing. I do not expect anybody to remember what wood grain or what light green or what red brick will generate. It's impossible because there's so many possibilities. So there are two very simple rules to remember. Number one, any color or pattern at minimum will generate 6 watts of power per square foot at minimum. That's rule number one. Rule number two, the darker the surface color is, the better it will perform. So minimum 6 watts per square foot. On the high end, you could be looking at 15 or 16 watts of power per square foot and anywhere in between. So those are the only two rules that you need to remember. Module shapes, depending on the design of the building, there are a lot of things that we can do with shapes. We can do curved glass. We can do variations of cell layouts. So there's a lot of different things that can be integrated into the design, as well as assembly shapes and, what do we do with returns and, different flashing. How do we deal with corners? How do we deal with deep, panel returns? What kind of textured glass do we have? All of those things are available. So there's a wide variety different textured glass and different design ideas to be, or that can be incorporated into the building. Working with architects early on is really important. Understanding that there is a really important element that architects need to be able to discuss with their clients, and understanding how color selection will impact performance. Understanding that there's different installation systems that are available, understanding what panel layout and electrical design looks like. So we like to get involved early so that we can address all of those issues. Firstly, so that you understand how that impacts the design, and then obviously being able to communicate that with your clients is really important. Finding that sweet spot between aesthetics and performance is really important for you and your clients to understand, because especially when we get involved early, we've had lots of projects where the client says, well, we're looking at a white facade, but I love the idea of generating as much power as possible. Well, if that's the case, then you might want to consider a darker color. If performance is really important, then we have to consider darker colors. But again, it's finding that sweet spot between what looks good, what's acceptable from an aesthetic perspective, and generating the kind of power that a client is looking for. System orientation is really important to understand as well, because not all buildings face true north. And understanding that all elevations generate electricity is really important, because the assumption is that the south side is the only side that generates electricity. That is not true. West and east are strong performers, and the north side will generate electricity based on reflected light, not direct light. So that will perform as well. In the end, you and your client may decide to eliminate the north side or stick with only the south side, and that's fine. But when we're assessing a building for its potential, we look at all four elevations so that you understand what the full potential is before you start eliminating elevations. We have a look, you can take a look on our website. We have an online project simulator, so you can see exactly how much energy the building could generate. So if you go on and type in, 10,000 square feet on the west side or 20,000 on the south side, whatever, it will tell you how much power that building could potentially generate. Testing is really important to understand. We have, as I mentioned earlier, we've been in the business for a very long time, and all of our non-solar and our solar technology has run the gamut of testing. So unlike a lot of other similar products out on the market, they do not have all of their testing certifications, so they can't go past the 6th floor. So it's really important to understand that we have run the gamut of testing. So we have tested for impact, missile impact. We have tested for windstorm, obviously fire, S-134, NFPA 285, freeze thaw, laboratory aging, strength, endurance, compression, tension, shear, buckling, torsion, you name it, we've done it. So literally there is no restriction to how high up we can go on a building. We guarantee our technology, for 25 years. So warranties are, we're putting our money where our mouth is. All of this testing information is available. So if anyone is looking for the full range of testing, that can be provided. Lead, if it's something that is important to you and your client, there are of credit potential, optimizing energy performance, advanced energy metering, renewable energy production, et cetera, et cetera. So it could be a potential 40 points for lead. Governments and companies are dealing with the issue of sustainability. It looks different, sustainability goals are different from one company to the next, but I think it's safe to say that, we're all sort of in the same boat, and hopefully we're all rowing in the same direction. So it certainly is a lightning rod topic. And so it should be. And, you know, this technology just supports those goals, which is all a good thing. So analysis and case studies, this is really important. So embodied carbon and life cycle analysis for a solar facade. So solar facade panels generate enough green energy to offset the carbon needed to produce them, unlike traditional materials. So here we have two comparisons, New York and Los Angeles. So in New York, south-facing Mitrex facade panels can offset the carbon needed to produce them in under 4 years and remove just under 2,500 kilograms of CO2 in 30 years. In Los Angeles, south-facing Mitrex facade can offset the carbon needed to produce them in 3 years and remove just under 2,900 kilograms of CO2 in 30 years. We have a lot of information for embodied carbon. So again, all of that information is available to you. The environmental impact is pretty clear. So in 2024, the U.S. Department of Energy developed a blueprint for decarbonizing U.S. buildings and aims to reduce greenhouse gas emissions from U.S. buildings 65% by 2035, 90% by 2050. So BIPVs can assist with achieving this goal. So in conclusion, when asked, you know, what the benefits are and why you would look at BIPV, there are different reasons from different perches. So from an architect's perspective, aesthetics has been a big challenge up until now. I have yet to hear of an architect that says, yes, I would love to put those hideous looking rooftop panels on the side of the building all the way to the 30th story. Said no one ever, right? So aesthetics is really important. That's been addressed. Installation systems available. High performance building envelope is there. Lead points are there. Code compliance with respect to testing is there. Fire testing is there. ESG and EPD reporting, it's all there. GCs love us for a number of different reasons. All of the ones that architects love, plus a few more. So, you know, from a building owner's perspective, after the warm and fuzzies are gone after a presentation, they're going to remember one thing, and that is, what is the cost? They're going to look at that one little tiny cell in an Excel sheet and go, it costs how much? And if they're not going, oh my God, this is great, then we're dead in the water, right? So BIPV won't be an alternative if the cost is too much. So that's the biggest thing, is the return on their investment is there. The affordability is there. The guarantee is there. Plus the fact that they are eligible for federal tax incentives. So that is super important. So hopefully now you will be able to recall the basics of solar energy and understand what the key components are. You understand at a very basic level what a BIPV is and how that can improve on traditional photovoltaics. And you understand ways to incorporate BIPV systems into either an existing construction for a retrofit application or for a new build. And you understand that there are, you know, energy savings possible through integration of BIPV and understanding how that applies. So that is the conclusion of this presentation. I'm going to stop sharing my screen now. I'm going to turn my camera back on. There we go. All right. So
Awesome.
I suspect there's going to be a lot of questions, so I am ready for rapid fire.
Great. As always, we do have a good amount of questions, and a reminder for everyone in the audience, feel free to submit any questions now to the Q&A. If we don't get to them live, we will have a record of it so we can follow up with you after the event as well. I'll just start at the top if that sounds good to you, Terri.
Of course.
All right. Can the panels come with integral insulation / R value?
So the panel itself, there's not a lot of R value there because it's aluminum honeycomb, first of all. And then there's not much between the EV layers and the glass facing. The insulation value really comes from, or the R value really comes from insulation. So in a rain screen application, it's adjustable. You can get a lot of insulation behind the panels, right? In our prefab wall solution, the insulation is integrated into the panel. So there's only so much insulation that we can include inboard. The rest could be outboard. So those are details that can be worked out once we have a project and we're analyzing it and we understand what the R value requirements are. Then we'll make recommendations based on the installation method and what the client is looking for.
Awesome. All right. How does cost compare to insulated metal panels?
Cost compared to so an IMP solution. I'm going to make some assumptions here. Whoever answered the question or whoever posed the question, I'm assuming that with IMP you're referring to applications like industrial warehouses, that kind of thing. So we have different solutions for those type of applications. The cost of an IMP is less than a prefab wall solution, but we do have a BIPV solution that we use in these types of applications. So for a warehouse or an industrial application, we have, it's like a rain screen application, but it isn't the substitution for the IMP. We would offer a second skin on top of that because our rain screen solution or our prefab wall solution is definitely pricier than an IMP. Kind of hard to compete with that. But it all depends on what the client's goals are. If they're looking for, power generation, then that might be something to consider.
All right. Can the glass mounted PV still permit solar gain for installations that wish to allow solar gain to collectors beyond?
I'm not quite sure what that question means.
Okay, yeah. I think whoever asked that question, if you could either provide some more clarity in the Q&A, or if you would like to raise your hand, we can unmute you and you can ask the question out loud. You don't have to turn your video on, but yeah, could be helpful to just kind of talk it out a bit. All right, moving on to any issues with glare.
No, not at all. And again, depending on the application, depending on where the building is located. So if we're using gloss finish, in a lot of cases, clients are looking to replicate a shiny metal. In that particular case, we would use a glossy glass finish. That could produce some glare. Or we have matte finishes, or you're looking for a textured finish and there's no glare on textured finishes. So it all depends on what the finish selection is. There's a lot of variety there.
All right. Would you use this for residential projects?
Residential high rise, yes. So if you're looking at an apartment or a condo building that is, a high rise situation, yes. Not for individual home projects, no.
All right. Solar rails, they say, perhaps I missed this, but are the railings clear to allow seeing through the panels?
It all depends on what the design is and what the intent is. So we could provide transparent solar cell, which maintains visibility. It looks like tinted glass from a distance, so you can still see through it, but transparent solar cell technology is not a very good performer. It's only 5 watts of power per square foot maximum. So it's not a lot of power. However, if the client is intent on integrating it into the balcony railing, then we do have that. Or we can play around with solar cells. So you can have clear glass in the middle and then maybe have 2 rows of solid solar cells on each side, which are visible. It's obvious that you're integrating solar cell technology. That's possible as well.
All right. Are there any projects that you have completed in the UAE or in the Gulf region?
We actually have a couple of projects completed in Dubai, and a number of projects that are currently being worked on.
Cool. What about any installations in California?
Nothing yet. So I want to make it clear. We formally launched our solar line in 2020. COVID, great, when the world, went to hell in a handbasket. I mean, things just went off the rails. So a lot of, it was kind of difficult to move forward with things around that time. And architects can appreciate the timelines of when a client, you know, sketch of something on the back of a napkin to the time you go to SPA and you have shovels in the ground. It's a 3 to 5 year process. We have a lot of projects in the pipeline in a number of different regions in the US. They are not built yet, but they are in our pipeline to be constructed over the next 2 to 3 years. So we have a handful of projects right now, but many to come in various regions, and California is one of them.
Awesome. All right. What about, are the products rated for hurricane zone construction?
Yes, they are. We are certified in Miami-Dade.
Awesome. All right. ROI will vary based on variables like location, energy costs, etc. But is there a range of ROI?
Okay, ROI, if the ROI question is as simple as how long will it take for my client to get their money back? In some cases, it could be ROI is immediate. In other cases, it could be anywhere between 3 to 5 years. I also want to say that ROI is dependent on two things. How much power can we get on the building? How much cladding space is there, or balcony space is there, or spandrel panel space, or whatever, to get as much active panel as we can. The more power the building generates, the quicker the ROI, number one. Number two, we base our ROI strictly on that delta between, if I go with metal panels, it's going to cost me 1 million. If I substitute metal panels and go with Mitrex, it'll be 1.5 million. That delta is that 500,000. That 500,000 could take between 3 to 5 years if you get nothing back from the government. But the fact is there's a 30% incentive, which means you got money coming back. So that ROI timeline is now reduced. So I simplify ROI by saying this. You have to clad your building. Whether you like it or not, you got to clad your building, right? So do you go with metal panel or, you know, GFRC or other materials that you're thinking of that give you nothing? You got to spend that money anyway. So spend $1 million on something that looks nice but gives you nothing, or spend $1.5 million on something that looks great and generates electricity for the next 25 plus years. Then get that 30% back from the government.
All right. Does the wiring need to be accessible for maintenance?
No. No. The only thing that needs to be accessible for maintenance is if a panel needs to be replaced for whatever reason, we can get to that panel. The connections are very simple, male and female connections, right? But all of that wiring is hidden behind the panel. Once that's plugged in, there's no need or reason to access it. And if we're replacing a panel, two questions that we ask. Number one, do we have to replace the panel? If the panel goes down for whatever reason, it's a daisy chain connection and there's bypass diodes on the back of every panel. So, you know, that ensures that if something happens to one panel, it just goes around it and continues to perform, right? So if one panel in 100,000 panels go down, there's no need to replace it. If a panel is damaged because a truck drove into it, that's a different situation. And if that's the case, then we'll replace the panel and then we can, you know, get to the connections behind the panel.
Right. All right, awesome. Can the glass mounted PV be installed over a passive solar trome wall?
A passive solar what wall?
Trome, Trombe.
I apologize. I'm not familiar with that term.
I'm not sure I'm familiar either. I think that was the same person who asked about something else we needed clarity on. So we do have a record of your questions. We can get in touch with you after the event. But again, if you want to raise your hand, feel free to do that and we can chat about it out loud. All right. Someone who asked about the projects in Dubai asked if you could specify anything about which projects those are, or if there are case studies that you could share. So I believe you have some case studies on your website. We've also got some case studies on Acelab, so you can head to either of those places to check that out. There is a link to the Mitrex and Cladify Acelab page in the chat, so you can grab that. You can also navigate to their website from there as well, so that'd be a good place to check that out. All right. Is the brick facing a 2D printed pattern?
So it is flat. It is, you know, from a distance, it looks like brick, and you might get the impression that, you know, there's texture and there's some, you know, but if you touch the panel, it's flat. Um, and again, if you go right up to it, you can tell that it's a print of a brick. But if you're, you know, 50 feet away from it and it's on a tower and you're looking up, you can't really tell.
All right. It looks like that might have wrapped up our questions. So again, for that person who had the 2 questions that we could use some clarity on, if I don't see your hand raised in the next few minutes, we'll just have a record of them so we can follow up with you afterwards. So I'll give everyone another moment or so if they want to drop any questions into the Q&A now. There's also going to be a quick survey when you leave this webinar where you can submit any questions that might come up as you're leaving to that survey. And if you could give us some feedback, that would be super helpful as well, so that we can continue bringing you content that's relevant to you. Also, other than that, there are quite a few links in the chat that might be helpful for you. There's Helen's meeting link. There's a link to the page on Acelab where you can get in touch with Terri directly and explore some more about their products, as well as I think a few other helpful items. So feel free to grab any of those links that you might need before you jump off for the day, as well as the AIA number and certificate request form. So if you can please get that done before the end of the day today. Certificates will be provided by the Mitrex and Cloudify team, and your credits will be reported directly to AIA. And if you have any questions about that, you can reach them directly through Acelab. All right, looks like we don't have any more questions coming in. So I think we can let everyone go a few minutes early, but just want to thank you so much, Terri, for a wonderful presentation and for being so on it with the rapid fire questions as always.
Yes,
and thank you
pleasure.
everyone in the audience for coming out today.
Thank you all. See
All
ya.
right, have a good one. Bye.